Hello, I'm Nimix, and this is how Tetris 2 was tasked. At the beginning of July 2019, I was going through a rough time with work, working almost around the clock to satisfy a deadline for a testing schedule for various people around the world. Around 3 a.m. one morning, I threw my hands up and decided to go play a game to unwind. Well, I ended up wanting to work a puzzle game and landed on Tetris 2. After a couple of hours of playing, I thought to myself, has this game been tasked? To my surprise, nothing had been done before. After researching a few points, I saw that an any percent was possible. At that point, the manual process of tasking started. Sometime around the first week of November, I had reached my height of frustration with this game, noticing the fact that manual tasking was absolutely not the way to approach this. To obtain an optimized movie, I saw that hundreds of thousands of combinations would be necessary to produce variations of the patterns that would yield the best times. So, this opened up the idea of BOTing. During my Thanksgiving holiday, I started writing a Lua script that would handle the manual process of checking every combination that I could throw at it. On December 2nd, 2019, I completed the first version of this bot, and the automation process was started from the very beginning. Immediately, I was surprised at how well it worked. Within hours, my best times for each round was being destroyed. Of course, as the game progressed, it got much slower, and it finally was completed about 2 years later, bringing the total time spent on this task up to 2 years and 4 months. So, what is the bot doing? A quick description: it automates the process of applying inputs to alter RNG, which in turn would produce different patterns on the next round. Here you will notice the original inputs that were used to solve round 23. These inputs will serve as a basis for how we will proceed to the upcoming steps. First, we will need to identify the frame ranges that the bot will be working within. Here at the beginning, frame 20,666 will be our starting frame, which is called our first frame of input. Second, we will identify the last frame of input here at 20,750. It is important to understand that this is the last frame that the game accepts normal input from the D-pad. We now have a special range that I call the cycling input frames, identified from frame 20,751 through 20,792. This range is used to further extend RNG combinations, allowing our normal process to be repeated up to 22 times. For now, let's move on, as I will explain this later. Finally, we have to obtain the ending frame for this round, which will be at 21,811. With these numbers, we are now able to instruct the bot to work exclusively within this frame range to apply RNG altering inputs, which in turn produce patterns of interest. Now that we have the range identified, the next step is to replicate the original solving inputs over to player 2. My bot has been fitted with an instruction to do just that. By performing this replication, we can now identify the original inputs from the template inputs that will soon be created. Next, we will use Task Studio to create inputs that will be used to alter RNG. It is important to understand that any input that has the ability to change our direction or orientation will affect the pattern seen on the next round. From my best observations, these changes can occur up to 42 frames after the last D-pad input is accepted for any given round. Anything afterwards has no effect. To get the most RNG changes, our inputs were divided into 3 groups: left and right, A, B, and down. With left, right, and down, these inputs can only be done one at a time. With A-B presses, they must come in pairs to reorient the solving piece back into the right position in order for the original inputs to solve the round. Once we have established these inputs, my bot was written with an instruction to save these inputs to corresponding files for later retrieval. So let's start it up and see what happens. You'll notice that it does a first run without anything to detect the next round's pattern. On the second attempt, a left or right input will be applied. Once all the left-right inputs have been exhausted, the bot will erase these inputs and add the first AB input at the top, only to start back at the beginning with the first left-right input again. So basically, I'm committing to a type of binary application from inputs created in the template for testing. What helps to make this possible is how I save the inputs over to player 2's side for identifying the difference between the original static inputs and the RNG inputs. This method provides us a safe way of reversing the changes to reset for a new run without destroying the solving inputs for that round. As this process continues, it goes all the way through to the D inputs. By this point, the bot has possibly ran for a day or so. Finally, to extend the possibility of more RNG combinations, a final set of inputs, known as cycling inputs, will help further define the change for newer patterns. If I were to go through a complete set of cycling inputs, it could possibly run a month or more. Along this long tasking process, the bot was updated 4 more times to include better functionality, efficiency, and accuracy. One particular item that helped to save tons of time was a check on patterns that were gridlocked. This is a situation where a good pattern exists, but a solving piece cannot get to it on the first drop. So, to eliminate these unusable patterns, I wrote a check routine called the wall follower. This routine is ran only when the original criteria is met for my pattern expectations. It basically determines if the piece has a clear pathway to the flashing blocks needed to be cleared away. And that's it. Of course, there's a lot more detail to how this process works, but that is an overview that should explain my approach to converting the tiresome manual effort over to an automated process. Please ask questions in the submission thread, as I'd be happy to discuss it further. Special thanks goes out to Wurzel, Dr. D2K9, and Aaron Yeager, also known as Eternus Dragon, for their collaborations and following. Thanks for watching.